So this is a fourth video on the subject of MIDI-based production, and with this one I'd like to take a look at some of the MIDIdef based solutions for, well, one will be for the very needed, must-have approach to playing with synthesizers usually, and another one is just to show kind of a direction to which we can go by exploring the flexibility of having a function that we can run when we get an arbitrary MIDI message. What is cool about MIDIdefs also is that by being completely independent from the synthesis node and anything that controls it, we can basically have several MIDIdefs, let's say note-on MIDIdefs, yeah, which will control one enddef, yeah. So you can see here, for example, I have let's say on channel 1 polyphonic wavetable synthesizer, yeah. The wavetable aspect of it and the DSP is something that specified by SynDef and controlled by enddef, yeah. But being polyphonic is about how MIDIdef is set up, yeah. Now I switch to channel 2 and I have the same thing, but now monophonic. Yeah. A must-have thing, and you can see I can switch between different ways of playing the same synth by just switching the channel, yeah. So let's take a look at how I've done it. So this is something like a Monophonic event pattern. That's what I was thinking about when well, wrote this couple of code blocks. I don't know how actually Monophonic is designed, but maybe it's kind of samey thing to what I do. The thing on top is just a polyphonic MIDIdefs, same as with the very first synthesizer in this MIDI series, so nothing new. I have, oh no, there is something new, but I had it already on a granular synthesizer, yeah, it was same. So I use MIDI node to start synthesis node and create an object, and I use it to stop the synthesis node and remove the object. But here I don't do that. Here I create the list for the notes that I will play, and I use conditional inside of the function, MIDIdef function. So the slot will always be the same, yeah, arbitrary slot. You can even hard code the number without having this slot global variable. So when the note is pressed, what I do, I check if this notes list is empty. If it's empty, and it will be empty if nothing was played before. So I add that note to this notes list and put the proxy, yeah, well, start the synthesis node and the corresponding put corresponding object, create corresponding object based on the synth-def name, yeah, on the synth-def name, whatever it will be, like, it doesn't matter like which one is there. The only condition is that it's sustained, yeah, it's a sustained, it has sustained envelope generator. Yeah, and notes. Yeah, okay. So, and I start the synthesis node. Now, if I then, while holding one note, I press the next note. Yeah, what I do then, I add a new note again to this notes list, and I set the existing synthesis node to a new frequency. Yeah, so that's how it becomes like that. And you can see the actual content of this slots. Sorry, this notes list. You can see that now frequency doesn't change because I still hold the last one, but the elements from array disappear. Yeah, so this is done in the next, in the note off block. And what I do here, again, a conditional. So I ask if the notes array size equals to 1, which means there is only one note pressed. Then I will just release the synthesis node, remove the object at that slot, and remove the node from the notes array. But if not, and this is the probably most interesting part, so I again set the frequency to the last added node to the notes array, to the last pressed one. Yeah. And so on. So this is how I made it. Works nice. Maybe there are some weaknesses, I don't know. If there is some, let me know, but like in most cases that I've played it, works nice. I didn't yet encounter any weak points with that. Okay, now let's switch here to channel 3. What do I have here? Not here 5 and here 3. Yeah, you can see there are also 3 other ensembles. And now if I press the key, one played, again press the same key, okay, but now another one is playing. So what happens is, when I press the key, there is some number of synthesis ensembles which actually being played by the MIDIdef. Yeah. How I do that? Because I then have to also keep information about how ensemble names are connected to notes. Yeah. For that I create another order or dictionary. Not a big deal here, unless you probably will do some crazy stuff with not with your hands but with some hardware or software. Then probably the dictionary will be more effective. Again, depends on what you do with it. It's said in help file of order that let's take a look. Order. Yeah. In some aspects it's more effective than dictionaries, but in other ones it's less. So put and add are slower than an identity dictionary. Yeah. But do is faster. So if you loop over it, over this data structure, this collection, then it's better to use order. If you do so, probably yeah, because we put and remove, so probably identity dictionary might be more efficient. But this only will matter if you play with something other than your hands. With your hands, you will not be able to stress I guess even a weak computer with that. So yeah, so what I do here, by the way, let's start with this part. This is also a cool thing. It's obvious that these can be arbitrary endeavs with the totally separate functions, so you can have a totally different DSP inside, and that's beautiful. I just wanted here to show that we can also copy endev with all of its internals, its internal effects cascade, and so on. We can copy it. For that, we only need to specify the new name, an object of a symbol class, and use this copy message, and that's it. So you say endev.copy new name, you will get a new endev with that name, and it also will appear in this endev mixer interface. And here I just create 3 new names based on the original name and by adding iteration number to it, and iterate over those names and add and copy original endev to every next one. Okay, so what I do here, I assign a name variable to a random name from this set of names, yeah, and then connect that name to the new node that I got from the let's say MIDI controller. Yeah, so I press the node, I assign that, I kind of connect that, bind that to the arbitrary name. Then I use that name and make that endev with that name play the node. Yeah, and it's random every time I press the node. It can also be a sequence, by the way. We can put these names in a certain array, for example, and just index this array here with some global counter or something like that. Or we can just make a routine with the array inside of which we will iterate recursively over an array. Then we will just say next to that routine, and routine will always return a new element from array. When it will reach the end, it will start from the beginning, and so on. Another way to do that with just an array is to use a modular operation. Modular operation, modular method. Yeah, so if I have something like, let's say from 0 to, let's say, 9, yeah, and modulate that with, let's say, 3. So I will have 0, 1, 2, 0, 1, 2, 0, 1, 2, and so on. Yeah, so that's how this math works. So we can use that to this method, for example, this simple method, to go over a certain sequence of endevs. Okay, I prefer just uniform probability here with this choose method as an example, just an example. Also, you probably know we can play with probabilities for the choice and create even a Markov chains and so on with this choose method for an array. So array of elements, if I recall correctly, array of elements, and dot choose, and the array of probabilities. So this is less possible, this is more possible, and this is in between. Yeah, point 6, 0.4. Yeah, these all these guys inside of the probabilities array should sum to 1. Oh, sorry, what am I doing? I shouldn't do. Okay, should sum to 1. There is a cool method called normalize sum, if I'm not mistaken, which you can use to take any number of any array and normalize it to sum. yes, to 1 basically, so that sum is 1. Also convenient. Okay, so if you have something like this, you can then, what, there is a syntax, got it, syntax 0.5, 0.4. Okay, is this right now? Yeah, you can see now it selects 3, but after many iterations you will see that 2 will appear more often than 3 will be next to it, and 1 will be less. Even here we can see that 1 appears less than others. Yeah, this can also be used. Okay. I put note here, so I will have this plain and defs as an order or dictionary. It will collect, bind the and def name to the note being played, and then we will use the same this actual plain and defs order to ask at when the note off comes which note was released. Okay, the note with a certain number will was released, and we will ask like which is the and def name that was assigned to that note. Yeah, and this way this method, for example, with freaking touchpad, with this at method will give us the actual name of the enddef, and then we just will use that to send it gate equals to 0 set message, and remove that slot from its internal structure. So that's how it works. Possibilities of creating interesting and fancy things don't end up here. Yeah, I guess you can imagine that you can even have like routines that run inside of enddef when you play a key. Yeah, that will give like abilities to play arpeggios and so on. Of course, with arpeggios probably there is no need for that, because we already have lots of those. I guess even in Ardour you can add something like a MIDI filter. Didn't use that much. MIDI. You can see there is some set of MIDI pattern and so on. Some set of processing modules for MIDI, which will do a lot of fancy things. I remember I read about that a time ago, but never used it. Yeah, probably in my case I will use some sort of routine if I want an arpeggiator. But the thing is, I also used to play arpeggios by hand. Okay, so why would I need legato? In my case, I usually want legato when I play bass. I'm hungry a little. When I play bass, yeah, I don't want in this low range, pitch range, to have polyphony. Yeah, so usually it will be something like this, not something like this. Sometimes might be interesting, but usually not. So let's record some stuff to the already existing material. You can see I recorded the outputs of one-shots from the previous video, one-shot samplers, just so that I don't waste anyone's time on a simple thing, but just to kind of note on some flexibilities that Ardour provides here. If we can, we can add several tracks in one go, yeah, like this, by specifying how many tracks, and so on. We can also assign them to a specific group. If there is no group, we will create that. Then groups allows us to specify what common qualities will the tracks have. As you can see, I have selection here and record enable here. These are important for me usually, and color as well, so I can color code them, and you can see that the color of the group is now reflected in the color of the regions. And if I click on one of them, they all get selected. If I press the record enable button, then they all get selected as well. And another thing is that, for example, I don't like that for solo, but anytime you can just press Ctrl and all the guys in the group will react to the their neighbors key press. And the last thing is that we also have this interface from Ardour that allows us to specify connections in jack-D. And so here's the Supercollider. You can see here other tab usually shows other applications. So I have Supercollider and the Ardour tracks in yellow. These are prepared for the recording. So you can just then draw a line here, something like this, yeah, and they all will be connected. Yeah, I will not do that now because I already done it. So that's it. I recorded it. I have it something what actually was before, yeah. Yeah, and I edited a little bit here just to specify what I'd like to use from that garbage that I created with the granular synthesizers for this, as well as for this track. There is also something fun here. Okay, some freaky solo. And let's also add a bass now. Add bass, why not? Yeah, everything is ready. So let's play some bass. I will start with the MIDI messages, then behind the scenes also will probably print it to a track, and some arpeggios. That's what I'd like to record. Now with this video, I'm very glad that this will be shorter than previous ones, because I think I usually make too long ones. So let's record. Is this connected? Yeah, this is connected. This will receive our messages. Oh no, let me first try what I actually want to play. What I want to play. Okay, I got it. Okay, that's enough. And arpeggios, yeah. Something like this. Yeah. Why? That's interesting. It looks like it didn't receive the... Did it receive that? Let's take a look. Looks like it didn't receive the MIDI off message. Not off. No. Oh, okay. This is how its recording mechanism works. Yeah. So let's try this. Everything is kind of in one set of chords. Yeah, very simple. Two set of chords, which can be also expanded to kind of 3 or 4 set of chords. We are very amorphic here, but let's try to compensate that maybe with the timbres. That's what I... Well, the initial chord progression is very simple. Yeah, that's why it kind of limits us. It's whether you develop further some chord progressions, new ones, yeah, or play with this one, but then everything will be much very simple. Yeah, but let's be very simple. Why not? This is a just a demonstration, yeah, of what we can do, of the tools, technical tools. Okay, something like this. And let's listen how it sounds with the bass. Oh, sorry. We have to connect that stuff. Yeah. We have to connect it to Supercollider now. And then Okay, I guess the picture is clear. I will do something behind the scenes and we'll make sure that it sounds nice. And with this and with the next one, I'd like to take a look at some more fancy tools with control signals and effects processing. Yeah, there is something to talk about that. So that's it for now. Let's see what how it comes next. 32 minutes. I guess that's good. Yeah, that's good. So see you.